Hey, so you've got your summary of the points of concurrency that you finished up, and you've been working on this worksheet. Okay, realize that the altitudes aren't easy to find. Okay, at least not at first. Okay, so just a quick reminder as you're going through it, take your right angle. So I have my right angle on my ruler here, and I'm going to line that right angle up with one of my sides, and I'm going to run it along that side until it hits that opposite angle up there. And once it does, that line from the opposite angle to its opposite side is your altitude. Okay? So as I'm sliding it along here and I hit, that's the altitude. And you do that for each one of those sides. And then make sure you put your right angle markings here. Those help you determine what you're looking at a later time. So I slide it along this side right here until I hit that opposite angle. It's like about right there, and there's my altitude. Okay, and the same thing on this one. Slide it along until you hit that opposite angle. Okay? That point of concurrency, called your orthocenter. Got it. Your medians, as you're going through that one, I just told you to kind of estimate where the midpoint is. So if the midpoint of this side's about right there, I'm going to go from that midpoint to the opposite angle. Remember, a median goes from an angle and it cuts that side in half. Okay? So going from the midpoint of this side to its opposite angle. Now, if we were really needing to construct this, we would have to measure it out, but right now we're just kind of estimating. Okay? Should have two markings there. They're not congruent to that. So midpoint to opposite angle. And we've got it. And that right there, that one's called our centroid. Remember, that's kind of the center of gravity. If you were to put a point there and balance it, you should be able to get that triangle to balance like on a tip of a pencil. All right, and then down here, if you've been looking at your different markings, it says AB is it a perpendicular bisector? Is it an angle bisector? Is it an altitude? Or is it a median? Or is it none of them? Well, AB here, if it hits at a right angle, that narrows it down. It can either be a perpendicular bisector or an altitude. And an altitude goes from the opposite angle and hits the opposite side at a right angle. This one is an altitude. Okay? If AB isn't at a right angle, then it narrows it down to either a median or a angle bisector. A median cuts a side in half. It bisects a side from the opposite angle, whereas an angle bisector bisects an angle going and then goes to the opposite side. So this one is a median because it bisects a side. This one is an angle bisector because it bisects the angle. How about number 10? It doesn't hit the right angle, so no altitude or perpendicular bisector. It's not coming from an angle, and it's not cutting a side in half, so therefore this is none. How about this one? Altitude. And this one? Perpendicular bisector. Okay, very good. Questions? Alrighty, go ahead and flip over to page 172 of your student journal. Okay? Alright, page 172 of your student journal, there's some extra practice stuff that we're going to go through, and I'm going to give you another note page that you can reference as well while you're getting there. You got your note page here. Okay, this is a kind of typed up, nice, neat summary of everything on one page. If you want it there, it might help you out. You can add whatever notes you want to the end here, but the the thing that we've added to this is the special properties. So note that a perpendicular bisector, which we call the circumcenter here, is equidistant from each vertex. So if I find the perpendicular bisector, so looking at this picture here, I've got this perpendicular bisector, and this perpendicular bisector. Notice they haven't been extended all the way like ours were. We stopped right where they intersect. From that point, that circumcenter, this is equidistant to each angle. That's the special property a circumcenter has. Okay? When I have an angle bisector, so if I take and bisect this angle, got this guy here, okay, they're equidistant from the sides of the triangle. That's its special property. It's like having special power. Okay, the median, the centroid of point R is 2/3 of the distance from each vertex. So this point right here is 2/3. Like this length right here is twice as long as this length. This length right here is twice as long as this length. So if you broke this line into 3 parts, this median into 3 parts, 2 of those 3 parts are closer to the angle than this third. So this length is 2/3 from that length, of the entire thing there. So this is 2/3, this would represent 1/3. Okay? This would be 2/3, this would represent 1/3. Alright, and then the lines containing the altitudes are concurrent to each other there. Okay, so we've got our different altitudes. Here's this point. And notice we've got our right angle. That was kind of the tougher one for you guys to draw there. Alright, so what I want you to do is I'm going to have you apply some of those special properties on in your student journal, problems 1 through 3 there. Okay? Go ahead and work with your partner. Get a go on it. Okay, just a bit of clarification from a question here. When I say that, when we're talking about this being 2/3, BD is our entire length. That would mean that BR is 2/3 of BD. Okay, so this length is 2/3 of this entire length. Okay, which means RD is 1/3 of the entire length. Okay. Hey, as you work through number 1, if I'm saying ND is equal to 2x plus 5 and NE is negative 2x plus 7, if we're trying to find NF, what do we know about these 3 lengths? They're equal, right? And when we have that, these are equal. You're dealing with an end center here. So we know that we could say 2x minus 5 is equal to negative 2x plus 7. Bring our 2x over, we get 4x. Bring our 5 over equals 12, so x is 3. And if x is 3, we can plug that back in to one of these to find out what that length is. So if this was 3, that would make that 6 minus 5, or 1. So the length of NF is also 1. And if I plugged in that 3 here, I better get 1. So that's negative 6 plus 7, which is 1. Okay? So NF equals 1. All right. Number 2, tell your neighbor what you got. And number 3, 7. All right. So there's our work there. Got 4 and 7 for numbers 2 and 3. Okay, once again, setting those equal. You're dealing with that end center. Okay. All right. Okay, I want you to go ahead and turn the page. I'll be around. You can answer questions as you guys are working on these next 4. Give those a go. Okay, look at the markings. You know, this is kind of confusing when you kind of look at them. They've erased this part, but if you were to extend this out, they're saying, hey, this was What is this thing? Okay, it's definitely bisecting this side. It's bisecting that side. Okay, this part right here was an angle bisector, right? Okay, angle bisectors. What do we call an angle bisector again? With this point, when we find our angle bisectors, what do we call the point of concurrency? The end center. So once we find the end center is equidistant from the sides. So that's kind of what they're trying to show there. They just don't show all the lines, but they've erased that part saying, hey, these were congruent. Okay? So like on this one, they're saying, hey, there was a line right here which made this a perpendicular bisector. There was a line right here making that a perpendicular bisector. Okay? So the point of concurrency that they found for that perpendicular bisector, the circumcenter there, we know that those are equidistant from the angles. Okay, that's what they're trying to show here. It's a bit confusing in the diagram if you're new to it. So go ahead and try numbers 4, 5, and 7 and ask questions as I'm cruising around. All right, so circulating there's kind of a mixed bag. Some of you really had them and you're done with all 4. Some were struggling a bit. But if I'm trying to find PA from here to here, we know that these distances are all the same. So PB, PA, and PC are all the same. This is 13 because that's 13. And that's 13. Okay? We know that perpendicular bisectors, we find that point of concurrency, they're equidistant from the angles. And we have an angle bisector, they're equidistant. That point of concurrency is going to be equidistant from the sides when we hit them at a right angle. So that's 8, and that's 8. So PS is 8. Okay? This one's weird, but we got that obtuse. We have our perpendicular bisectors. Those are equidistant from the angles there. So this is going to be 10. And equidistance from the sides, NF is going to be 2. All because that's 2 and that's going to be 2. Okay, so just recognizing those. Questions? All right, last piece. I want you to take a look at number 8. Find the coordinates of the circumcenter of the triangle given the vertices. So first thing you're going to have to do is plot the points. And notice you have some negatives in here. So as you're going through and trying to plot those, make sure you use the correct grid, okay, so that you can fit everything on there. All right? Alright, we've got ABC. This is a right triangle, makes it a little easier on us. We're finding the circumcenter. Remember, the circumcenter is which point? In order to find the circumcenter, we have to find the perpendicular bisector. So we bisect each side. That's nice. Okay. Makes it a little easier with the grid. It looks like our perpendicular bisector is going to be right there, even without bisecting this side. But if we were to draw in that other bisector, it goes something like that. So the coordinates of that is 2 and 1. All right. For those of you who did the other two triangles, there they are. 6, 3, and -1, -5.